for all of us. The Honorable Mr. Muhammad Hoiri, STM PhD, as Head of Department, Lecturer and Researcher at Civil Infrastructure Engineering ITS. The Honorable Mr. Mehrdad Hejazi, as Associate Professor in Structural Engineering Department of Civil Engineering and Transportation, University of Isfahan, Iran. And the Honorable Insinyur A.Yusuf Zuhdy, Lecturer at Civil Infrastructure Engineering. And the Honorable participant of webinar series in this morning. Okay, Alhamdulillah. First of all, let's say thanks to God who has been giving us guidance, happiness, healthy, and mercy, so we can attend and participate in this event without any obstacle, even though this event must be held by online. Before that, let me introduce myself. My name is Nafisa, as the Master of Ceremony who will host this webinar meeting. Okay, this event is the 7th webinar of series in Civil Infrastructure Engineering webinar series in 2022. This 7th webinar series discuss the topic of nanotechnology in construction. Okay, ladies and gentlemen, on this nice occasion, let me deliver the structure of the event today as follows. The first is opening, second, singing Indonesia Raya and ITS hymn song. Third is opening speech from Mr. Muhammad Hoiri. Fourth, reciting prayer. Fifth, main lecture from the speaker, followed by discussion, question and answer session. And the last is certificate submission session and closing. Okay, entering the next agenda, singing the song Indonesia Raya and ITS hymn. The audience has to strain their seat and mute the mic so they can sing Indonesian national anthem solemnly. The commit on that is welcome.
Indonesia tanah airku, tanah tumpah darahku. Di sana aku berdiri, jadi anggur ibuku. Indonesia kebangsaanku, bangsa dan tanah airku. Marilah kita bersatu, Indonesia bersatu. Hiduplah negeriku, bangsaku mereka semuanya. Bangunlah jiwanya, bangunlah badannya untuk Indonesia. Indonesia. Indonesia yang merdeka, merdeka, hiduplah Indonesia yang Indonesia merdeka, merdeka, tanahku negeriku yang kucinta. Indonesia yang merdeka, merdeka, hiduplah Indonesia.
Okay, the next agenda is opening speech. The speech will be delivered by Mr. Muhammad Hoiri. For Mr. Muhammad Hoiri, time is yours.
Good afternoon, ladies and gentlemen, all webinar participants. Assalamualaikum warahmatullahi wabarakatuh. Our distinguished speaker, Mr. Mehrdad Hejazi from Structural Engineering Department of Civil Engineering, Faculty of Civil Engineering and Transportation, University of Isfahan, Iran. Participants, ladies and gentlemen, I'm pleased to welcome to you to this webinar on the topic related to infrastructure engineering and nanotechnology. This webinar is part of our series Civil Infrastructure webinar in 2022. This is a 7th webinar in 2022. It aims at providing and sharing information to our students, alumni, and some of our lecturers also join in this webinar. And this webinar also strengthening international exposure to our civil infrastructure engineering. And may will help us to open joint collaboration activity between University of Isfahan and ITS in the future. And ladies and gentlemen, I believe that by participating in this webinar, we are in the right place, so in the right time, that together let us accelerate the exchange of idea and information, especially on this today's topic, nanotechnology in construction. Besides that, maybe we can also exchange the information about the construction environment between Iran and Indonesia. I wish you all are get a very successful webinar today. And thank you very much. Please enjoy to the webinar.
Okay, thank you for Mr. Muhammad Hoiri for the speech. Next agenda is reciting prayer for Kamit Ondati, time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Selamat siang, hadirin yang berbahagia. Marilah kita berdoa dengan khusyuk dan ikhlas menurut agama masing-masing. Izinkan saya akan memandunya secara agama Islam. Marilah bersama-sama kita menundukkan hati, mohon ampun, seraya mengharap agar doa kita dikabulkan oleh Allah Subhanahu wa Ta'ala. Bismillahirrahmanirrahim. hamdan na'imin, hamdan syakirin, hamdan yukafi mazidah. Ya Rabbana lakal hamdu kama yanbaghi li jalali wajhik. Allahumma sholli ala Muhammad ala ali Muhammad. Ya Allah ya Tuhan kami, tiada kata dan rasa yang pantas kami haturkan kepadamu sehari ini. Selain syukur kami padamu atas segala nikmat dan hidayah yang sudah Engkau anugerahkan kepada kami, sehingga kami bisa hadir bersama untuk mengikuti kegiatan webinar series ke-7 yang diselenggarakan oleh Departemen Teknik Sipil Institut Teknologi Pendidikan. Yaitu ya Allah ya Rahman ya Karim, jadikanlah acara kami ini sebagai acara yang Engkau ridhoi, yang membawa barokah, rahmat, taufik, dan hidayah-Mu buat kami semua. Ya Allah, Tuhan yang Maha Mengetahui, ilmu-Mu begitu luas dan tak terbatas. Limpahkanlah kepada kami semua kekuatan dan kesabaran, kemudahan dan keikhlasan, serta kecerdasan dan kearifan selama webinar ini. Berilah kami ilmu yang bermanfaat, kefahaman yang luas, dan amalan yang Engkau terima selama kami mengikuti webinar ini. Dan berilah kami kemampuan untuk menerapkannya di masyarakat. Ya Allah yang Maha Pengasih, jadikanlah kegiatan ini sebagai amal ibadah dan dapat terlaksana dengan baik dan sukses. Ya Allah ya Tuhan kami, Engkau-lah yang akan mengabulkan setiap permohonan kami. Rabbana dolamna anfusana wa ilam ilam takfir lana tarhamna lana kunana minal fasiqin. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzabannar. Alhamdulillahirabbil alamin. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Okay, thank you for Brian who has recited the prayer. Okay, before entering the main event of today's webinar, let's take a photo. For the audience, you can maybe able to on cam first, and for the commit on dati, you can help with documentation. Okay, here we have 3 slides, so we'll take a photo per slide. We're going to the first slide. 1, 2, 3. The second slide. 1, 2, 3. And the last slide. 1, 2, 3. Okay, thank you for the commit on dati for helping us to take documentation. Next agenda is the main event of presentation from speaker followed by discussion, question and answer. Moderator on this webinar will be handled by the Honorable Insinyur A.Yusuf Zuhdy. For Mr. A.Yusuf Zuhdy, time is yours.
Okay, thank you, Zuratun Nafisa. Good afternoon, everybody. Here, I am A.Yusuf Zuhdy as moderator in webinar right now. Here, I present Mr. Hejazi for speaker. I inform Mr. Mehrdad Hejazi from Department of Civil Engineering, University of Isfahan, position as Associate Professor and specialty in structural engineering, traditional structures, historical building and restoration. Of course, we will have collaboration more and more after this, Mr. Hejazi, because we serve a student in magister degree in restorasi. This is the dress of Mr. Hejazi. in Isfahan. And then cell phone, email, you can read it. And the most important thing, membership of international and national academic societies, research has been made by Mr. Hejazi also. Doctoral degree, PhD in Structural Engineering, University of London, UK, 1992 to 1997. There about publication, project, a lot of project. I think that's all for introduction. So I call Mr. Hejazi for delivering presentation. Please, Mr. Hejazi, your time start now.
Okay, thank you. Do you hear my voice?
Yes, I got it.
Thank you. Thank you very much. Let me share my screen. If you have my screen, then I can start my presentation.
Yes, I got it.
Okay, if there is any problem, please let me know. Okay, thank you very much, everybody. I should thank very much ITS for inviting me today for the webinar, especially Professor A.Yusuf Zuhdy, who is the contact person between two universities, and also Dr. Hayri and all other professors there, and also the students who are present today in this webinar. For this webinar, I tried to make very simple issues about nanotechnology in construction, and I just focus on very simple and basic issues, as I assumed that most of our audience are from students. What I'm going to explain in about 40 minutes, I will give you a short introduction. Then I go to basic concepts of nanomaterials. Then we go to nanotechnology in construction industry and application of nano in works of art, and at the end, conclusions. Well, let's start with the introduction. I just try to move this from up. Sorry, I need to move it somehow. I don't know how. Just a moment. Okay. If we go to the meaning of the word nano, nano comes from ancient Greek nanos, which means dwarf. And as you know, as engineers, 1 nanometer is about 1 billionth meter, which is very, very small. And if you want to make a filling the size of 10 hydrogen atoms together is less than 1 nanometer. Or even the width of a DNA strand is about 2 nanometers. Or a sheet of paper, which we daily use, is about 100,000 nanometers. To get a better feeling, if a person is 2 meters high, it is actually 2 billion nanometer high, which is very, very high compared to nano. Or if we go to DNA, it is in the scale of nanometer. And also if we go to atoms, it is less than a nanometer. Here you can see, this is the scale if we start from here, which is 1 nano, until here, which is 1 millimeter. You can see when we go for DNA, we are around 1 nano. When we are atoms, it is 0.1 nanometer, and so on. Therefore, the subject is very small, and it is very difficult to deal with. Therefore, when we say nanotechnology, it is concerned with materials and other phenomena in dimensions less than 100 nanometers. Here we have nanomaterials which are stronger than normal materials. They are more durable. They are self-healing. They are air purifying. They are easy to clean. They are waterproofing. They are fire resistant, and so many other good advantages and characteristics. Let's go back to the origin of the idea of nanotechnology. It goes back to Professor Richard Feynman. To the right, here's when he was young, and in the left, when he became a bit older. He gave a famous lecture in December 1959, and the title was, "Is there plenty of room at the bottom?" And he put forward 4 questions in that seminar. First, is it possible to replace atoms? It means to move them or replace them. 2, is it possible to make very, very small machines with dimensions of a few atoms? Or can we make wires made of atoms? And the last question was, do the laws of physics resist these elements? And for answering these questions, he suggested awards, $1,000 for a person who builds the first electric motor with a maximum size of 1.6 cubic inches. It became into reality 1 year later, and he gave that money. And the second was a prize for someone who can shrink a page of book to a size that can be read with an electron microscope, which is very, very small size for a book. And about 26 years later, it became to reality, and that person got his prize. As you can see, the Richard Feynman was the pioneer in about, say, 60 years ago. During this time, if we go back, those audience who are in my age, they remember that it was in the 90s, at the last decade of 20th century, that myself, I got familiar with nanotechnology. It was about 1998, which I was working in Department of Serving Engineering, and at that time there was a request from the government that you should go for nano dimensions in serving engineering, and at that time it was very difficult for us to do that. And it was in the beginning of 2000, around like that, which nanotechnology became popular. And today that we talk about nanotechnology, it is common in the world. And as you can see, from the beginning of 21st century, in different areas such as chemistry, computer science, biology, physics, engineering, and so on, there is a lot of usage of nanotechnology. Let's have a quick look at the concepts of nanomaterials, and then we go to the usage of these materials. Well, similar to ordinary mechanics, in nanomechanics, we have zero dimension particles. We have one dimensional nanotubes or nano fibers, as you can see here. Also, we have two-dimensional nanoplates, and also we have three-dimensional nano solids. As you can see, everything in nano dimensions is very similar to ordinary mechanics. But the problem is we are dealing with some issues or some materials which we cannot touch them or we cannot see them. It is very difficult to deal with these dimensions. Well, as you see here, today there are so many applications in different disciplines. As you see here, for example, building materials, which is related to our expertise, say energy, manufacturing, transportation, even textiles, even metals, even in medicine for surgery or so many things, electronics, ceramics, sensors, and so on. Lots of usage of nanotechnology today exists, and we can use that. I'm going today to give some examples for these issues. There's a question, important question: how we are able to make nanomaterials? As you see here, there are two ways. The first way is top-down, which means breaking down ordinary material into smaller particles in dimensions of nano. The method we use could be chemical methods or thermal methods. This is mostly related to people expert in chemistry, and the other issue is bottom up, which means building complex systems by combining simple atomic level components. It means just combine smaller atomic size in order to make larger size to become nanotechnology, nano dimensions. Therefore, as you can see, the technology must be so developed in order to produce such nano structures or such nano materials. In order to make it very simple, the top-down method is mechanical grinding. In order to grind larger say issues into smaller issues or smaller particles, and the top if we use wet chemical methods, it could combine both top-down and bottom-up methods. These methods are very complicated, and those who are expert in chemistry and so on, they know how to do that. For example, here we have Sol-Gel process, which is a very famous one, which goes from up to the bottom, and using some chemical activation and so on, we go or we reach in nano dimensions such as thin film coating or powders or dense ceramic, which are in nano dimensions. And the other method is gas phase in a furnace, which is a task by chemists who do some thermal processing in order to make nanoparticles from smaller particles using heating and so on. We in our expertise usually don't go to the process of making nanostructures or nanomaterials. Rather, we use the product. We use nanomaterials, such as nanopowder, which I will explain. We use, say, nanosilica in concrete or cement, or nanotubes. Again, we use, for example, in concrete and so on. As you can see, mostly nanomaterials could be three-dimensional, could be two-dimensional, and could be without dimensional, such as particles. For example, the nano ZNO, which is a chemical component, as you can see, it could have so many different shapes and applications. It means that during the thermal processing, it is possible to give different characteristics to the same material. Therefore, it is a very diverse technology, and according to your need, you would ask for the chemist or those people to produce whatever you need. Let's go for some general applications, mostly related to construction and to civil engineering. As you can see here at the top, top right, you have concrete, ultra high performance concrete, which is very strong, very strong. And then here in the middle, you see the use of nanomaterials in vehicle converters, which makes it very efficient. And at the bottom, you see using nanomaterials as additives used in paints and coatings to give specific characteristics to the paint. I will explain it more later. Here you see antibacterial ceramic tiles, and you see they are very durable, and they are very clean, and they are protected by nano. Or here you see some anti-scratch metal used for walls, as you see here. They scratched very difficultly. You can scratch it very difficultly, and also usually they shine and they are very bright and clean. Sometimes we have a problem with pipes, water pipes or sewage pipes. When we discharge, say, sewage, sometimes you have some sort of sound underneath, under the floor and so on, which is annoying. Nowadays, they use nanotechnology to make silent pipes, usually inside, and when liquid or sewage or water is passing, you don't hear any sound from this. One of the important usage is the protection of carpets or textile by Nano in order to prevent them from becoming dirty or even become wet. For example, when a glass of water is poured on your let's say suite, on your trousers, on your chair, on your carpet, and you are afraid of being wet, by Nano you can protect around becoming wet. Or also you have a nano textile which become dirty very late and you don't need to clean them every week, for example. And one of the important things is about health facilities, antibacterial health facilities. When you use it in a washroom and so on, you don't need to clean it every day. It could be cleaned every week or every month, and when it is protected by Nano, it is clean, and also it is hygiene without any problem. As I said before, textile is very important because in every daily life we use textile like this. Using nanotechnology, it is possible to you see here the lotus leaf. As you see, if you have seen, when a lotus leaf is in water, as you see here, it never becomes wet because of this, as you can see here. The same technology could be used for textile in order to protect them from wetting. As you can see here, in this picture at the bottom, if you have textile, the nanoparticles work in that way, that they have two ends. The upper end is hydrophobic layer, which means it does not absorb water, and that's the reason if you have a hydrophobic layer here, the water just remains here and it does not penetrate to the textile like this. And you have enough time in order to clean it or to remove it by something else. As you can see here, the sol gel method, which I quickly showed you here, is used for such a process. As you see here, the main material is nano silica, which is SiO2, and in order to, we're doing some chemical reactions. Sorry, they are in Farsi language, but I think you can get feeling from this. As you can see here, we have a combination of SiO2 with some additives, and these additives are nano materials. When they combine together, they prevent water from penetrating to the textile. Well, let's go to the use of nanotechnology in construction in industry, which is our daily life. Well, some good characteristics that they have, I mean, the nano materials or nanotechnology is to solve our daily problems, such as elimination of pollution of living environment or working environment. It means, especially for this situation today that we have with COVID-19, and we try to make inside space clean, it could be used. Also, sometimes we need very strong steels or metals. It is possible to improve mechanical properties of metal by nanotechnology. For steel, specifically, we have corrosion problem, and especially when you are against, say, in some atmospheres near sea or something like that, using nanotechnology, we can use anti-corrosion coatings for steel in order to protect it. Or for concrete, which is very much used in civil in construction industry, and concrete has many problems. In order to improve the performance and also to repair the concrete, nanotechnology today is very good help. Also for glass, different types of glass, nano could improve the features, and also for wood, especially for those atmospheres which is humid, such as in your country, using nanotechnology can increase the durability of wood. And as I explained before, for ceramic tiles that we need antibacterial, antimicrobial, and self-cleaning features, nano is one of the best options. And also for insulations, to preserve energy, say thermal energy, we can use nano insulations, and even for acoustic insulation today, we can use nano insulations. In order to summarize the characteristics, I go to, if you see here, concrete, steel, glass, cement, which I'm going to explain about. As you can see, the nanomaterials in concrete is SiO2 and Fe2O3. The first one gives proper armament, makes it more strong, and the second one prevents concrete from cracking. I will explain later. When you have steel, if you add copper nanoparticles, it would increase the quality of its weldability, and also it would increase its corrosion resistance. For glass, we use TiO2 and SiO2, which gives the features of self-cleaning, fireproofing, and anti-heat penetration. For coatings, again, we use TiO2. For solar cells, we use TiO2. For cement, we use carbon nanotubes and polypropylene nanofibers in order to increase resistance, general resistance, and fire resistance. And also for sensors, which we use for monitoring using nanocarbons, carbon nanotubes gives a better performance to sensors. I'm going to give some examples for concrete, steel, glass, and cement. Okay, first we go how we can eliminate pollution in the atmosphere of our office or our working space, working office or living room. As you can see here, the material which is used for this is titanium dioxide, TiO2. It is nature friendly, and it is very friendly to humans, which means that we as you see here, when we have some pollution in the air, and you know that we have some vapor, some water in the air, TiO2 reacts with water, with the oxygen, and it releases OH radicals, and somehow it decomposes NOx in the air. NOx is the pollution, and then after reaction, it is converted to a harmless gas, which is HNO3. By this method, the NO something, which is not good, it changes to HNO3, which is good. And this is the process that if you use titanium dioxide in your living space, it somehow pollutes the air in that space. Well, let's go to steel. As I said before, if in the process of producing steel alloy, we use copper nanoparticles, it would somehow form the boundaries of steel grains, and then makes it or changes it into a very strong steel, which is very strong to resist more load, and also it increases its weldability, and most important, it increases its resistance to corrosion. Therefore, when you need high performance steel, one way is to use copper nanoparticles. Well, cement and concrete are widely used in all parts of the world, and in order to increase, one of the main issues that we are very interested is to increase its strength, say compressive strength. And the other thing is somehow to increase its durability or decrease the possibility of cracking and so on. For this reason, nano tubes are mostly used, or sometimes nano particles. Before nano, we used at the moment we use nanosilica in order to improve the properties. Before nano, we used microsilica, but at the moment we use nano. And when we use nanosilica, because it is very, very small, it goes to the voids inside the concrete mix and make a high performance concrete with these features. For example, when we use concrete on the floors on a parking, for example, on which every day hundreds of cars drive, and after a few years it wears, if you use nanosilica, it would increase its anti-wear properties. Also, sometimes concrete is slippery, and if we add it, then it would become anti-slip. For fire protection also, we are able to use nanosilica, also in order to increase its resistance and also its strength, I would say. It is one of the best options. And also one problem that concrete has sometimes is water penetration, in which water goes inside the concrete, and after a while the steel rebars would corrode. In order to prevent water penetration, using nanosilica is one of the best options. Also, another option is nano titanium dioxide, which gives self-cleaning property, antiseptic property, and it increases its brightness. One of the main problems that we have with exposed concrete is when it is rainy, after a while, you will see some stains on the concrete. Therefore, if we add nano titanium dioxide on the surface, it would act as a self-cleaning agent, and it protects the concrete structure against those problems which might have with rain or somehow. The other material that we can use is carbon nanotubes in concrete, as you can see here. And the main reason for adding nanotubes is preventing cracking. It has an additional positive advantage, which is increasing the compressive and flexural strength, which is not that much. It is about 30 or 13%, which we could achieve much more than this percentage by nanosilica. But here, when we have problem with cracking, we usually use carbon nanotubes, as you can see here, which makes the concrete repair automatically itself. I will explain it to you later. Also, when we use carbon nanotubes here, it makes a hydrophobic layer, and it prevents water penetrating the concrete. And it is very useful where we have concrete structures near sea, or when we have concrete pipes to convey sewage. The inside surface of concrete pipes could be inside, or the whole concrete pipe could be used or could be strengthened by nanocarbon tubes. And also, when we have concrete piles, and sometimes they are inside water, also it is a good idea to use carbon nanotube in order to prevent from corrosion. And as I said before, the main advantage of carbon nanotube is its smart crack repairing characteristics. The method is that when we have crack here, when there is a crack, it might be a very tiny crack inside the concrete. At the same time, the capsules or nanotubes would break, and when they break, they start to increase their length somehow, and somehow they repair themselves, or they repair the concrete, and the crack would disappear after a few days or weeks. An application of nanotechnology in concrete could be seen here. It's a church in Rome. It is called Jubilee Church, as you can see here. It is made of concrete blocks, as you can see here. And because it's very tall, it is difficult to clean it every often. And therefore, they used the titanium dioxide with self-cleaning effect in the mixed design of the concrete of this church. And as you can see, it is very clean and very bright, and no need for everyday cleaning. After concrete, let's go to glass, which is very important in anti-reflective glasses, sunscreen glasses, fireproof glasses, and self-cleaning and easy-to-clean glasses. I will show you one or two examples for each case. First, we start with anti-reflective glasses. As you can see, when you have a car at night, usually you have the problem you see here on the right mirror. You have some sort of reflection of light. But if you look at the left figure here, after you use anti-reflective materials, it's very clear without any problem. There are different ways to make anti-reflective glass. One very good method is to use a very thin layer of silica, which is made of nanoparticles. And today, in most of the mirrors of most of the cars, this technology is used to solve the problem. Sunscreen glasses, it could be for a window or for eyeglasses, for example. They use a layer or a coat on the glass, which is nano coating. It could be on the window glass, or it could be on eyeglass in order to filter somehow the infrared or the UV or ultraviolet. And using nano coating or nano materials nowadays is one of the best solutions. But those eyeglasses which are made in this method, they are a bit expensive. Let's go for fireproof glass, which is very important in some cases. I will explain. One solution is use silica nanoparticles in order to make the glass fireproof. And it depends on different standards. In most standards, a fireproof glass must have a minimum of 2 hours resistance to direct flame with a temperature of about 1,000 degrees centigrade, which is too much. It's a very difficult criterion. But by nanoparticles of Si2, we are able to make such a product. Now I show you. I hope you can see this. Again, I'm showing you a movie about fireproof glass. As you see, I just stopped. As you can see to the left, there is a flame, and to the left, to the right, there's a person who is touching the glass. And as you can see, it seems that the heat is not transferred between. It is not transferred through the glass, as you can see. Okay. Here you see a real application which is used in German post office in Bonn, in Germany. It is a very high building, and many employees work there. And as you see in post office, it's very important because many documents, many letters, and so on, they come to this building, maybe, and after that, they go to the people. For example, if there's some sort of fire in the building, it is possible that documents, important documents, would be destroyed. And therefore, both for the external facade and also internal, say, barriers or internal spaces, they use fireproof glass in case fire happens there. Different spaces could be protected for at least 2 hours, and there's enough time to distinguish the fire or rescue the people or the documents. We go to another application of glass, which is self-cleaning glass, nano coating. Again, here we can use titanium dioxide nanoparticles because it has a very good cleaning or self-cleaning properties. It doesn't allow any dirt to stick to the glass. If rain, if you have rain, there's no problem, and it cleans the mud inside the or with the air, and also it prevents from formation of fingerprints on the glass, and also it keeps the glass clean for a long time, and therefore you don't need to clean the glass every week or every month like that. And again, here the hydrophobic layer is produced on the surface, and this prevents water or liquid to make the glass dirty. Again, I show you another short movie, as you see here. Okay, here I stopped or paused. Here you see that there is glass and water is poured on the glass. Okay. This is an ordinary glass. Now we'll change the glass into a nano glass, and you see the difference. Here you have the nano glass, and you see water doesn't stop. It quickly goes away. And this is the mechanisms. Again, ordinary glass and nano glass. Here and here. Therefore, if water or liquid goes quickly from the glass, it doesn't make it dirty. Good. One important application is in the glass of the cars, especially today with air pollutions. We have problem with this issue. In this, I show you a movie. There's a glass of the car. The left side is ordinary glass, and the right side is coated with nanoparticles. Now look at this. As you can see on the left, water sticks to the glass, but on the right side, water does not stick. And this is the technology that today many car production companies use in the glasses of cars in order to make it more clean and make it dirty resistance. And here are some examples. As you see, these photos are taken from Tokyo in Japan. And you know, Tokyo is near sea, and there are very high rainfalls every day or every week. And there are very tall buildings. And many of the buildings in Tokyo, or the facade, the external facade is in glass. And it is not possible for them to clean it every day or every week. It's very time consuming. As you see here, they are very clean, and they are not. They have not been cleaned for 2 or 3 months. They have used they used nano coating for these buildings, for these glasses, to make it clean. Now we go to wood. Wood is very important, especially in those countries or atmosphere which is lots of rain every day or every week. And you know that rain or water somehow deteriorate the wood. Therefore, if we use some coating made by nanotechnology on the surface of wood, as you can see in these photos, the wood would be protected, both from water and also sometimes UV. If as you can see, as you see, when wood sometimes is exposed when wood is exposed to sun, it becomes dark because of UV action or effect, and it is possible to protect it from UV. Here, there's an example. There's an example in Switzerland near Lake Zurich, and as you can see here, near the lake, it is always raining, And in Switzerland, they are very nature friendly, the people, and they try to make the facade of the building, if it is possible, with wood. And in order to protect the wood, they need some solution. And one of the best solution is use the nano products to protect the wood. Let's go to ordinary life again, to ceramic tiles, as I explained before. Again, come back to here again. Here we see the trace of TiO2, which is a very clean or very cleansing component, a chemical component. It is antibacterial, it is self-cleaning, and it is air purifying. As you see here, say it is a washroom, or here is a bathroom, and here you have the tiles. There are two methods. One is to apply coating, spray it on the ceramic, and the other is using nano materials during the production of ceramic. Both solutions could be, or both ways could be used. Okay, let's see this movie again. We go to the end, and I will explain after it is finished.
Painted with this exterior masonry paint, and it's like that paint. And here is a big glass box. Oh, look at that! In and out. Look, I'm not cheating. You see, there's the man on the back. Look, I think I need to do this. I cannot believe it. How does that work? This is apparently all due to the miracles of nanotechnology, apparently. Personally, I think it's the devil's work.
Well, as you see, there is some mud, and there is a ceramic tile here. One side of the ceramic tile is ordinary one, which is in the back, and the front is somehow treated with nanotechnology. As you see here, when it inserts the ceramic inside mud, this surface, which is treated by nano, there is no mud here, but as you see on the back side, which is ordinary, you see the mud. It means that it is very useful to use such a material. Nano coatings has another application, which is anti-graffiti. Unfortunately, today in most of the countries and most of cities, we have some. There are some people who do or make gravities, and one of the best solution is to add a coating of nano, which doesn't allow the graffitists to write anything on the wall, and even it could protect the wall from scratch and abrasion. Even in solar panels, which are usually black in color, we use carbon nanotubes. And when carbon nanotubes are used in the production of the panels, they absorb about 100% of sunlight energy, and they increase the efficiency of the panels up to 100%. The other application is the insulation, thermal insulation. As you know, aerogel has been recently used in many industries. It is very low. It means it is not heavy at all. 90% of its volume is porosity and cavity, and it could be used whenever we need a very lightweight, and also we use it when we need thermal or even sound insulation. Aerogel is thermal insulated. It is very transparent. It is fire resistant, and it is sound insulated. And the technology used in aerogel is nanotechnology. It is one of the best and most successful usage of nanotechnology. Let's go to the last part. The part before the last part. The usage of nanotechnology in asphalt. As you see, when we have asphaltic pavement in the roads, one main problem is that after a few years, it goes. We see some cracks, and maybe we need to repair it physically or somehow replace it. If we use nanomaterials in the asphalt, it has an automatic. If we use, say, polymeric material in nanoscale to the asphalt, it makes the asphalt to repair the cracks and grooves automatically, and you don't need to repair it every week or every month. Maybe you have noticed that in some streets in your country, or maybe in some other countries, that you see very clean, very good and intact asphalts. It doesn't mean that this asphalt was made a few days ago, but it means that maybe there are some components inside, like microcapsules here, which are in the asphalt, and after and every time a crack happens, the crack breaks the microcapsules, and then microcapsules again come together and close the gap between the two sides of the crack. The last part I'm going to explain is about the application of nanomaterials in works of art. Usually when we use nano in works of art, in most cases, the objective is to repair or to restore the object. But for restoration of objects, we have some limitations. We should keep into the principle of reversibility, to principle of minimum intervention, to the principle of using chemicals which are chemically ineffective, and the materials should be compatible with the main material of the work of art. I will explain later. There are some paintings. The left paintings are before treatment, and the right side are after treatment, as you can see here. There's a big difference here. But the thing is, the value of the paintings is not just because of the appearance, which should be clean or not, good or bad, but the value is with its originality and authenticity. It means that during the restoration work, we shouldn't make any change in the originality of the object. For this reason, our treatment should be reversible. It means that whenever we decide to remove what we did or what we added, it should be possible. For example, if sometime these people decide to remove the material from the right and make it back to the left, they should do it. Therefore, this is one. The second is minimum intervention. It means that you should use the materials as little as needed, not more than needed. If you use it more than needed, it is not acceptable. The other, the material should be chemically ineffective. It means that it shouldn't do any reaction with the main materials of the object. And the last one, the materials used should be compatible. For example, if the main pigments of the main is, say, with the basis of say Zn, for example, the material that we use for treatment should be based on Zn in nano particles. Also, we should be aware of some environmental risks of nanotechnology. Nanotechnology is a young technology, and in addition to its advantages, it might have some disadvantages. At the moment, the main problem that it might cause to human body is its very small dimensions. It means that if you have nanopowder and you smell it, it would directly go to your cells and it would go to your tissues without going to lungs and so on. It means that that is the reason that those people who work with nanopowders, they should use face masks in order to prevent to take it inside the body. Also, that would be difficult, or that could be dangerous to other animals. Therefore, the usage of nano should be in a way that it couldn't go to the body of human beings or human or animal bodies and so on, because it also silica and titanium dioxide, which were very good and they were very useful, if they are in direct contact with the human body, they would cause a problem with lungs, and they cause pneumonia, which makes the person die maybe in 2 or 3 days. Therefore, that's the reason that all countries have very tough standards for producing nano materials in order to make the health of people is secured. Let's go to conclusions. I think I have talked about an hour. If I summarize what is said, when we say nanotechnology, we deal with materials or system with dimensions below 100 nanometers. They are very small. And the advantages, as I say, for the materials, they make stronger, more durable, self-healing, air purifying, easy to clean, waterproofing, and fire-resistant materials. I thank you very much. I try to say it as simple as possible, and I hope you have enjoyed it. If there is any question, I'm ready to share my opinion with you. Thank you very much.
Okay. Thank you, Mr. Hejazi, for your presentation. And now, before entering the question session discussion, I would like to ask to you, Mr. Hejazi, your presentation, your material is not concerned in acoustic. Yeah, I think your sol gel, yeah, more effective in acoustic. Yeah, just that's just my opinion. Okay, everybody, raise your hand if you have a question to Mr. Hejazi. 1, 2, raise your hand. Okay, who is? Isan Anwari. Okay, please ask to Mr. Hejazi directly.
Okay, thank you, Mr. Yusuf. Of course, thank you so much for the attention, Mr. Hejazi. Yes, introduce me, Disan. I'm from student from Institute of Technology School November, from Indonesia Sipil. First of all, we knew that there's a lot of benefit for the nanotechnologies, and such as the environmental sustainable. And we know that so many beneficial things that like waterproofing and fire resistance. There's new to me for student to hear the nanotechnology. So my question is, in the future, is that the nanotechnology is more expensive than a conventional materials that we know, like maybe concrete or steel? And besides, we know that how the nanomaterials is formed, there's a lot of things to do, like there's a top down and bottom up things that can form nanomaterials. So yeah, that's my question. Is that the nanomaterials is gonna be more expensive than conventional things nowadays? Thank you, Mr. That's my question.
Thank you very much, Mr. Anwari. Good question. Well, nowadays it is an expensive industry, the nanotechnology and nanomaterials. The anticipation is in long term, the distance between the expense of common materials and nanomaterials would decrease anyway. But again, in future, we will have two types of materials, common materials and advanced materials. And depending on the project that you work or dependent on the type of material that you need, you must make a decision between your budget and the usage that you need. But in general, in future, that would be more popular. Similar if we compare today with 20 years ago. Today, it is much more popular. Nanotechnology and nanomaterials are much more cheaper than before. And I guess in maybe 20 or 30 years later, that would be the same trend. They will have cheaper materials and more effective materials.
Okay, thank you, Mr. Hejazi, for the answer. Back to Mr. A.Yusuf.
Okay, any other question? Mr. Hejazi, would you please to explain if the side effect of the usage of nanotechnology bring to human, can we use the nanotechnology inside the material? Because as I know, you said that nanotechnology will work in surface of material. Is it right? Yeah. Then we change the place, the surface to the inside of material itself.
Okay, good question. Let me clear something. Maybe I did not clear it during my speech. Nanomaterials, as you know, could be used both just on the surface or inside. I mean, during the production. The example is the concrete. For concrete, you can make ordinary concrete and then make a layer on the surface, or in the concrete mix, in addition to, say, cement, aggregate, and so on, you can add nanosilica at the same time and make it. Therefore, we have already both of them. But the problem is, if nanoparticles are detached from that structure whatsoever, from inside or from surface, that would be dangerous. And that's the reason the production or the production process must be that after the structure is constructed, it shouldn't somehow put particles outside. And that's the reason. At the moment, we don't have any problem with that. It means that there are some enough standards. The problem is with the people who are in the industry of production at the moment, because somebody who is making concrete with nanosilica, he must be very careful in order not to touch the silica at the moment. Therefore, in total, there is no problem. There is no problem about it. We just must be careful when we produce it to make all the measures.
Okay, thank you, Mr. Hejazi. Any other people, audience, who wants to ask? Just raise hand. Mr. Hejazi, Do you mind to read the chat?
Yes, I read it. Thank you. Let me see from the beginning, and I think there is one question.
The last one.
The last one. How expensive the tools or laboratory equipment to produce the nanomaterial? For example, nano carbon tube for the laboratory scale. I would say in order to produce nanomaterials, you need a specific laboratory and a specific equipment. At the moment, only a few countries are able to produce, for example, nano carbon tubes and so on, because they are only those countries who have the equipment. And also, when you want to buy these materials from them, it is very expensive. Okay, it means it depends on the money that you put to your production. But on the other hand, there are different industries. I make example of my own country. In Iran, we do not have that many laboratories for producing, say, nano carbons and so on. We prefer to buy it from outside. But in the medicine industry, Iran is one of the pioneers in the world. It means that for the drugs or for some materials which we need for medicine, government has made a big budget for that. And at the moment, we don't need to buy those materials from outside. And because in a way, a few years ago is about 20 years ago. It was exactly in 2000. The government made an outline for the country in nanotechnology, and they received to this decision that for industry, it's better to import from outside, from other countries. And for the medicine, it's better to produce it inside the country. Therefore, it's a decision of the budget, of the expertise that you have. And there is a reality that one country could not make everything inside. And therefore, sometimes it's better to buy from other countries in order to make the industry inside. It depends on the country, the economical situation, and so on.
Thank you very much, Mr. Hejazi.
Okay. Other question? No worries. If apabila Bapak Ibu sekalian atau saudara-saudara sekalian mempunyai pertanyaan, bisa disampaikan dalam bahasa Indonesia. Monggo, siapa yang mau bertanya? Please raise hand. Siapa yang mau bertanya? Halo. Are you with me? Mr. Hejazi, do you mind to tell us the ratio between using of nanotechnology and conventional technology?
Could you repeat, please?
Do you mind to tell us the ratio of using technology in construction compared to conventional technology?
Actually, I didn't exactly your question, but I try to answer your question. You should repeat it again. Sorry.
Comparison of nanotechnology costs to conventional costs.
To what? To functional costs, you mean?
Conventional, traditional.
Okay. Well, in order to compare, it's better to explain something before that. If I want to make an example from composite materials, which today everybody knows about composite. Composite materials are very strong and very, they are not heavy, and they are expensive compared to conventional materials.
Yep.
The thing is, composite materials are not used in everywhere. They are used in industries which are possible, or it is rational to do that. For example, in aircraft industry, or in car industry, or even for our laptops, which are very small laptops, we use carbon ones. Or sometimes in construction, in order to retrofit, or in order to strengthen the material. Therefore, in the case of composite materials, they are not used everywhere. They are used where they are needed. It's the same for nano materials or nanotechnology. We are not expecting to use nanotechnology everywhere. We use it only where we need it, and it makes high advantages. And also for these high advantages, we have to pay. Okay, therefore it's a balance between the advantage and budget again. Wherever conventional materials resolve a problem, usually we should do that. We go for that and not use nanotechnology. Wherever we need the conventional materials or methods does not satisfy our needs, therefore we need to accept it, or we need to pay more to resolve the problem. Therefore, I think the advantage and cost should come together in order to make the decision.
Okay, thank you, Mr. Hejazi. Audience, all audience, do you still have any question?
Can I myself ask a question to you about nanotechnology in Indonesia?
May I ask something, Mr.?
Sure.
Mrs. Amalia.
Yeah, thank you. Mr. Hejazi, I'm interested about the nanotechnology in asphalt production that you explained, that self-repairing asphalt from the idea start from 2006. Its growing crack caused the microcapsules in the structure of the repaired asphalt to rupture and etc. How about the characteristic after it's self-repairing? How the characteristic of Marshall test or something after the asphalt self-repairing itself?
Okay, let me share my screen. I think your question is on this slide. Oh, sorry. Wait a minute, sorry. I think your question is on this slide, and your question is how it works. As I have explained here, well, the start idea, yes, it was about 15 years ago, and now they use microcapsules. They could be made of carbon or other materials, which is compatible with asphalt. And as it is written, I have written here, as you can see, when the asphalt cracks, somehow it tears the microcapsules or cracks the microcapsules which are inside the asphalt, and they automatically start increasing their length. And when they are enlarging, somehow they close the gap between the two sides of the asphalts. It means that if I show you this, wait, if I show you this slide, which was in concrete, but the function is the same. Just a moment. Here. Not yet. Okay. If you have a look at the right picture, here you have nanotubes, which is different from nanocapsules, but the function is the same. When a nanocapsule breaks, then it starts growing. And when it starts growing from one side, it goes to another side, like here, as you see, and somehow this crack is again filled with capsules, and you don't see any crack. That's the way it works.
So the stability or the flow or Marcel questions or something is getting better before after the self-repairing, yeah.
After repairing, it's the same as before. You don't notice any crack. You don't see anything in the asphalt.
Okay, thank you, Mr.
And you see, it is a constant process. It means that every time that car goes through the asphalt, if there's a crack, a small crack, it immediately the capsules grow, and it is a constant. I would say, phenomena for many years, and it means that you never see crack on the asphalt after its lifetime. After maybe 20 years or 25 years, which the lifetime is finished, then the asphalt should be replaced.
Is there any other indicators how big the crack is that itself can be repaired by the nanotechnology?
A very good question. It should be a few millimeters, not more, not centimeters. It's a good question. Now, if it becomes centimeters, no, it is not possible. A few millimeters at most. A good question.
Thank you, Mr.
Thank you. I have myself a question to you. As I explained in Iran, nanotechnology in medicine has progressed very much in medicine. We are one of the pioneers. How is it? On the other hand, in engineering, no, we import everything, almost everything. How is the situation in Indonesia on nanotechnology?
For construction, I think we don't use nanotechnology, but in an industry, yes, we got it. So material used products produced by industry, material for construction. There are a lot of material used nanotechnology. But for construction itself, I think still nothing.
Maybe I know the reason. I guess I'm not sure. Maybe the quality of common construction in your country is better than our country. In Iran, the standard of construction, both the structure and the material, in many cases is not good. I wouldn't say not good, but it is not as high as it is expected. Therefore, if we have an important construction site or an important construction building, and we see the conventional method does not answer that construction, then we go for using nano materials to do that. Maybe one reason that in your country, nano is not very much used in construction technology yet, maybe the standard of your construction is somehow high and you don't feel any need to do that. Maybe, this is what I guess.
We are in Ashar praying, so stop at the moment. Yeah.
Okay.
Okay, everybody, Azan is finished. Mr. Hejazi, still have one question. Are there any other challenges for using nanomaterial in construction except on health issues?
Except from health issue, there is financial issues. It means that you need in order to research, it needs lots of money, and it is not guaranteed that it would reach an acceptable result. That's the reason even some European countries, they are very reluctant to put large monies on that, except they are sure that they can. Therefore, somehow it is risky at the moment for the governments to put money. But history shows that those governments who made enough money for that, they succeeded. One is in my own country. In medicine, we did it. Therefore, the other thing at the moment is the risky budget. That's the main after the health.
I think using nanotechnology, just like asset or property, we need big money in the early or beginning period. But then after that, in operational period, the cost is getting lower and lower. Is it right, Mr. Hejazi?
Exactly. I accept it. It is like everything. For everything, at the beginning, you need money. But after that, it becomes popular. That's it. You will get back your money.
Okay. Okay. Discussion is already up. The time is already up. So, applause to Mr. Hejazi. Thank you very much. We have learned. We have a lot learned from your knowledge, Mr. Hejazi. I hope we will meet again in the other webinar.
Hopefully. I also... okay, carry on.
The time I deliver to Master of Ceremony. Thank you.
Okay, I myself also thank you and your colleagues and your students to provide this situation for me to exchange our knowledge together. And I wish that we could continue our collaboration, not only online, but hopefully personally. You and your colleagues and your students are welcome to come to Iran whenever, and I hope that even we are able to come and see you personally. Anyway, thank you very much, and I wish you a pleasant afternoon.
You are welcome. Don't leave. Don't leave. Not yet. Hello, MC. Okay. Where are you?
Okay, well, thank you to Mr. Yusuf as the moderator and Mr. Hejazi as the keynote speaker for being willing to fill out today's webinar. Okay, so previously there will be a certificate submission which will be represented by Mr. Hoiri. The commit in DATI can be helped by sharing screen.
Mr. Hejazi, please receive our thank you for your willingness to become lecturer today, and please receive our certificate for you. Thank you very much, Mr. Hejazi.
I thank you very much. It's my pleasure. Thank you.
Okay, before we end today's webinar, let's take a photo. The audience may be able to on cam, and the commit on that documentation can be assessed. Okay, here we have 2 slides. So we'll take a photo per slide. We're going to the first slide. 1, 2, 3. Second slide. 1, 2, 3. Okay, finished. Thank you for the comment on that, for helping us to take documentation. Okay, before we going to the next session, webinar participant who have not filled in the attendance can fill in the attendance first, where the link is in the Zoom chat. Okay, Alhamdulillah, we have reached the end of the event. Thank you very much for the speaker, Mr. Hejazi, and moderator, Mr. Yusuf, and also participants who have listened to the event from beginning to end. So hopefully a lot of knowledge can to be applied in everyday life. See you in the next webinar series. On behalf of the Committee on the T, I apologize for the wrong answer, for the wrong action and words. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Bye bye. Assalamu alaikum.